Hi there guys, I just thought we'd get together this time and have a look at some fractional enlargements. So in other words, where you enlarge and it gets smaller. So if I enlarge by a scale factor of a half, it's going to be half as big as what it was. So if I think I'm going to go 1, 2, I've got 2, 4, 6, 8 along the bottom there. So in my image I'm going to have 4. Here we've got 2, 4, 6, 8, 10. So half in that up here, I'll have 5. So this here is my image A dash. And I need you to notice again the idea of the rays. If we join the corners together using a ray, the ones that correspond, you should see, if I've drawn it well, that they all cross through a single point, and that would be the centre of enlargement. So I'm starting this one with the centre of enlargement, and the centre of enlargement about O. So here's my O. I'm going to draw my rays in. I might just do these one at a time. Now if I go from O to this point, I go 1, 2, 3, 4, 5, 6 that way. 1, 2, 3, 4, 5 that way. So in order to make that half as big, I have to make this distance half as big. So I'd said 6 groups there. Let's go into actual squares. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12. So I need to go 6, 3, 4, 5, 6. So I know it's going to be on this line. And then up here, I've got 1, 2, 3, 4, 6, 7, 8, 9, 10 to get up to there. So I need to go 5 up to half that distance. 1, 2, 3, 4, 5 to get there. So in my image, this point corresponds to there. And if I do one for the next point, let's do this one. I can see that I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 to there again. And here I'm going 4 squares up. So I need to go 2 squares up to find the corresponding one with that. And then coming to my final one, I've got 12, 13, 14, 15, 16. So I want to be 8 along for this one. And how many up is it? 4, 5, 6 up to get to there. So in order to half that, I need to go 3 up. So I need to be at a point here. So it's quite tricky to draw that ray in. But there we are. So my image is here. That's T dash, that's my image. So notice where this was 6 up there, this is now 3. It's hardest to tell on the diagonals. And finally, if the centre enlargement isn't at the origin, we have to think about those rays again. This time I want to enlarge by a scale factor of 1/3. So if I come from here up to here, I go 1, 2, 3, 4, 5, 6 double squares. So I'm going to go by 1/3, I'm going to make that go by 6. So 6 double squares, or 12 squares, I divide that by 3. I get to 4, and then here 6, 7, 8, 9, 10 and a half. Well, that would be 21 squares. 21 squares from here to here. Divide that by 3, I get 7. So that is there. If I then pick a different point, I think it's quite easy to see that it would be there. And if I pick a different point, the remaining point, I think it's easy to see that it would be there because it's a square. So you can use a bit of intuition. I could have said, okay, this distance from there to there is 12, so I need to divide that by, it's not 12, it's about 11.4, and I need to divide that by 3. So what's 11.4 divided by 3? Divided by 3 is 3.8. So this distance here should be 3.8, and it is actually. So here I just looked at the difference in the x and the difference in the y. So I'd gone 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 x's, and then 1, 2, 3, 4, 5, 6, 7, 9, 10 y's. So I had to divide my 12 by 2 to get 6, my 10 by 2 to get 5, and at 6, 5, that was where the point met. And with this one, I had to divide all those distances by 3, whether you do it in a direct line by measuring, or whether you do by dividing the x's by 3 and dividing the y's by 3. A final look at that one. To get from here to here, you go 1, 2, 3, 4, 5, 6, 7, 8, 9 across, and you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 up. So 9 across divided by 3 would give me 3 across. And you can see from there I did go 3 across. And my 12 up would give me 4 up when I divide it by 3. So it takes me perfectly to that. So different ways of doing it, but it's still following that idea of drawing the rays in to show us the position of the center of the enlargement, and remembering that the image for a fractional enlargement is going to be smaller than the object. Okay, I hope that's clear. Thank you.